Welcome to another episode of learning. Please like my videos and share them with your friends and colleagues. Please join as a member in my channel and support me and my channel. Please subscribe my channel if you have not already subscribed. Thank you. We continue the discussion of the solutions of the problems that have appeared in the CSIR National Eligibility Test July 2025. In this video, we discuss the solution of a problem from the section Linear Algebra, and this problem is related to similar matrices, and it is really further related to Jordan canonical forms of the matrices. This question is placed in part C, which is a multiple select question. There may be more than one answer and it carries 4.75 marks. The question ID is 562954151. Further, this question is suitable for all these examinations. Right. The given question is, which of the following matrices are similar over the field of real numbers to the matrix capital A is a 4 by 4 matrix whose first row is -1, 1, 0, 0, second row is 0, -1, 0, 0, third row is 0, 0, 1, 1, and the fourth row is 0, 0, 0, 0, 1. And we are given 4 options. Option 1, a 4 by 4 matrix, option 2, option 3, and option 4. Right. Let's now discuss the solution of the problem in detail. Observe that A is in the Jordan canonical form. Look at A, and it is -1, 1, 0, -1. This 2 by 2 Jordan block corresponding to the eigenvalue -1. Jordan block of size 2 corresponding to lambda is equal to -1. And here it is the 2 by is a Jordan block of size 2 corresponding to the eigenvalue lambda is equal to 1. So these are the two Jordan blocks. So A is equivalent to the Jordan form of J2 of -1, comma J2 of 1. You can also write the plus circle also. Along the diagonal, these are the Jordan blocks of size 2 each. Right. Therefore, the characteristic polynomial of A, denoted by chi suffix A of x, is same as the minimal polynomial of A, m suffix A of x, is x plus 1 whole square into x minus 1 whole square. Right. By seeing the Jordan canonical form, we can write this characteristic polynomial and the minimal polynomial. This means to say 1, -1 are the eigenvalues of A, and the algebraic multiplicity of each of the eigenvalue is 2. Agreed. Now, since the minimal polynomial has repeated factors, it is in square, it is also square, in repeated factors, A is not diagonalizable. So, A to be diagonalizable, the minimal polynomial, the factors must occur only once. That is, the factors must be linear factors. Here it is square is there. That means the minimal polynomial has repeated factors. Therefore, A is not diagonalizable. Whereas if you see the matrix in option 4, this matrix, you see this is a real symmetric matrix. And we know that every real symmetric matrix is diagonalizable. Therefore, the matrix in option 4 is diagonalizable. We see that the matrix in option 4 is diagonalizable. Since it is a real symmetric matrix and we are using the result, every real symmetric matrix is diagonalizable. So the matrix given in option 4 is diagonalizable, whereas the given matrix capital A is not diagonalizable. Therefore, they are not similar. So, the given matrix A and the matrix in option 4 are not similar. Therefore, option 4 is not true. Option 4 is not true means the matrix given in option 4 is not similar to the given matrix A. Right. We continue. Right. That is A, and the information related to A is jotted down here. We go to option 2. This is the matrix. And we discuss option 2 here. Let the matrix of the option 2 be C. This you say C. Right. Because in option 1, the matrix we said B afterwards. So let the matrix of the option 2 be C. Look at this matrix. It is the companion matrix. So notice that C is the companion matrix, and a matrix of this form 0, 0, 0 minus C naught, 1, 0, 0 minus C1, 0, 1, 0 minus C2, 0, 0, 0, 0, 1 minus C3 is called a companion matrix. And we know for a companion matrix, the characteristic polynomial and the minimal polynomial, they are equal and equal to C naught plus C1x plus C2x square plus C3x cube plus x to the power of 4. You have to remember this. So for this, therefore, chi C of x, the characteristic polynomial, m C of x, the minimal polynomial, is minus 1 plus 0 times x plus 2 times x square plus 0 times x cube plus x to the power of 4. And that is minus 1 plus 2x square plus x to the power of 4. Observe that 1 and minus 1 are not the eigenvalues of C. You can check. So 1 and minus 1 are not the eigenvalues of C. Therefore, A and C are not similar. If they are similar, the matrix C should also have at least the eigenvalues 1 and minus 1. They are not similar. Therefore, option 2 is not true. Agreed. We go to the option 3 in the next slide. Right. This is the matrix in option 3. We call this matrix as the matrix D. Right. And you observe that this matrix is a block diagonal matrix. So partition D into 2 by 2 blocks. D is equal to P I2 0 P, where P is 2 by 2 matrix 0 1 1 0. I2 is the 2 by 2 identity matrix. And if we want the characteristic polynomial chi D of x is determinant of D minus x multiplied by I4 is equal to 0. That when you evaluate, that will be the characteristic polynomial of D is determinant of P minus x I2 0 P minus x I2, and this will be determinant of P minus xi2 multiplied by P minus xi2, that is P minus xi2 whole square. And the determinant of AB is equal to determinant of A into determinant of B. That will come down to be determinant of P minus xi2 whole square. And the determinant of P minus xi2 is, take P, subtract x times I2, you get this matrix. and the determinant when evaluated you will get x square minus 1, and that will be x square minus 1 whole square, and that is x plus 1 whole square into x minus 1 whole square. What we see 1 minus 1 are the eigenvalues of D, and the algebraic multiplicity of each eigenvalue is 2, just like A. We also write this is A, JCF A, D, the characteristic equation, the characteristic polynomial of D is here. And, now, we have seen that 1 and minus 1 are the eigenvalues of D, and the algebraic multiplicity of each of the eigenvalues is 2, even for the D also. It's just like A. And in order to show that this D is equivalent or is similar to A, we calculate for lambda is equal to 1, D minus lambda I4, lambda times I4. So this is the matrix, and reduce it to row reduced echelon form, then you get this matrix, and the rank of this one is 3 because there are 3 linearly independent rows. So the rank of D minus I4 is 3. Therefore, the nullity of D minus I4 will be 4 minus 3, that's equal to 1. We are using Rank-Nullity theorem, right? So thus the nullity of D minus I4 for lambda is equal to 1 is 1. Will tell you the geometric multiplicity of the eigenvalue lambda is equal to 1 is 1. With this, there is one Jordan block, right, that I will talk later. We move to lambda is equal to minus 1, and D minus lambda I4. Lambda is minus 1, this will be D plus I4. So add I4 to the D. You get this, reduced to the row reduced echelon form. Again, you got 3 linearly independent rows in the row reduced echelon form. Therefore, the rank is 3. The nullity of D plus I4 is 4 minus 3, that's equal to 1 by Rank-Nullity theorem. Thus, the geometric multiplicity of the eigenvalue lambda is equal to minus 1 is 1. So, for both the eigenvalues 1 minus 1, we have the algebraic multiplicity is 2 here, and the geometric multiplicity is 1. This will tell you we have one Jordan block corresponding to geometric multiplicity is 1. One Jordan block of size 2 for each eigenvalue 1 and minus 1. So that as D is similar. D is the Jordan canonical form of D will be diag J2 minus 1 and J2 of 1, which is same as the JCF A. So since they have the same JCF, they are similar. Thus A and D are similar. Thus option 3 is true. Agreed. We move to the leftover option, option 1. This is the matrix, right? And call this matrix as the matrix B, right? And now notice that B is the companion matrix. Yes, it is looking like that, right? We know how to write, and for a companion matrix, the characteristic equation and the characteristic polynomial and the minimal polynomial are equal and equal to this. Therefore, chi of B of x, minimal polynomial of B of x is this we have written 1 times 1 constant plus 0 times x minus 2 times x square plus 0 times x cube plus x to the power of 4. This is 1 minus 2x square plus x to the power of 4. This is precisely equal to x plus 1 whole square into x minus 1 whole square. We also see for this matrix A, chi of A of x, the minimal polynomial of A of x, and the minimal, they are equal. They are equal. So it gives a suspicion that this A and B may be similar. So what we are arguing, as in option 3, for lambda is equal to 1 and lambda is equal to minus 1, for both the eigenvalues 1 and minus 1, we have the algebraic multiplicity is 2 and the geometric multiplicity is 1. It is only a repetition of arguments, and that is why the details are omitted, and if you have any doubt, you check it. So this implies that we have one Jordan GM is 1 means one Jordan block of size 2 for each of the eigenvalue, lambda is equal to 1 and lambda is equal to minus 1. Thus, the JCF of B is diagonal, along the diagonal, Jordan block of size 2 corresponding to the eigenvalue minus 1, J2 of 1, the Jordan block of size 2 corresponding to the eigenvalue 1. And this is precisely equal to the JCF of A. So therefore, they have the same JCF. Therefore, A and B are similar. A and B are similar. Thus, option 1 is true. Summarizing all the options, the answer to this question is options 1 and 3. That is the detailed discussion of the solution of this problem. To me, this problem looks to be little tedious. Little tedious. It will take time in the examination. Working out this kind of a problem will take longer time. However, I say that this problem is an interesting problem. I am sure that you understood the solution of this problem. Thank you for watching this video. Please like my videos and share them with your friends and colleagues. Please join as a member in my channel and support me and my channel. Please subscribe my channel if you have not already subscribed. Yes, I am sure I am going to meet all of you once again in another episode of learning. Enjoy learning mathematics. I wish you all the best. Thank you.